Hey guys, this is going to be the video over arithmetic sequences. This is our last unit of the year, so one more test and then the final exam if you're not exempting. So again, last unit, and this lesson is not too bad, so I don't feel too bad for not being there. You're going to be okay. Alright, so an arithmetic sequence is, well, first of all, a sequence. It's just a list of numbers. There is an order to them, and there, you have the first number, second number, third number, fourth number, and so on. But an arithmetic one is one where you're adding the same number or subtracting the same number over and over and over. So to get from one number to the next number in the list or in the sequence, you're just adding or subtracting the same number each time. So here's the formal definition. A sequence of numbers is called an arithmetic sequence if the difference of any two consecutive terms is constant. So the difference of two consecutive terms, so terms that are numbers that are right next to each other, is constant, which means the same each time. This difference is called the common difference, D. So we're going to use the letter D a lot for arithmetic sequences, and that D represents the common difference which is the number that you're adding or subtracting to get from one term to the next. All right, so let's look at an example. We've got 2, 6, 10, 14, 18, ... So it keeps going. This 2 is the first term in the sequence. We're going to be calling that T1. That stands for term 1, which means the next one would be term 2, term 3, term 4, term 5, and it just keeps going. So that's how we will label them. They're T for term, and then the little number next to it stands for which number it is in the sequence. Okay, so let's figure out the common difference for the first sequence. So you're figuring out to get from 2 to 6, what did I add? 4. To get from 6 to 10, you also add 4. So for each one, we added 4 to get to the next term, which means the common difference is 4. Okay, let's look at the next one. So to get from 17 to 10, well, now I'm actually going down. So I'm going to subtract 7. To get from 10 to 3, you subtract 7. And each one of these, you subtract 7, so the common difference is -7. The common difference. So you are going from, like, when you go to the next term, not a previous term, to get to the next term, what do you need to do? You need to subtract 7, so that's the common difference. That's our D. Okay, let's look at a couple of examples where we're going to figure out if it's an arithmetic sequence. So first, to do that, we're going to write the first couple of terms of the sequence, the first 3 terms. And then we'll see if there is a common difference. So there's different types of sequences that we're going to talk about over the next week. Arithmetic is just one of them. So later on, you're going to be asked, is this sequence arithmetic, geometric, and so on? Okay, so we're trying to determine today just, are these arithmetic? All right, here's how you get the terms in a sequence. So this Tn is just saying I'm looking at the nth term of the sequence. So to figure out the first term, I'm going to plug in 1 for n. I'm just going to put 3.5 instead of a fraction. That sounds easier. Okay, now I'm going to get T2, the second term. So I'm going to plug in 2 for n. Okay, let's get the third term. Nine plus 1/2 is 9.5. Okay, so to get from term 1 to term 2, what do I have to do? Add 3. To get from term 2 to term 3, again, we just add 3. So it looks like this one is arithmetic since I'm adding 3 each time. So D equals 3, and yes, this is arithmetic. All right, next one. So we're going to do T1, which means since I'm replacing this n with a 1, I'm going to replace the other n with a 1. So 3 minus 7 equals -4. T2, 3 minus 7 times 2. 3 minus 14 is -11. Three minus 21. Okay, so there's my first 3 terms, and you could keep going, but let's check and see if we can tell. So from -4 to -11, we have to subtract 7. To get from -11 to -18, again, we subtract 7. So yes, this one is arithmetic. And D equals -7. I know negative numbers are not necessarily our strong suit, so just a heads up, you could type this in the calculator just to see what the common difference is. So on this last one that we did, I could do -11 minus -4. So doing T2 minus T1, and that gives me -7, and then I could do -18 minus -11. So you subtract the term from, you subtract the previous term from the term, and then that gives you the difference. So -7 on both of those. Okay, next one, we actually already have the sequence written out. So go ahead on your own and try to get the common difference, and then, or see if there is a common difference, see if it's arithmetic. All right, pause the video and try 3 and 4 on your own. All right, so on number 3, we're adding 6 on the first one, and then from 9 to 27, actually adding 18. And again, in your calculator, you could do 9 minus 3, okay, that's 6, and then 27 minus 9, 18. Okay, and then if you keep going, it gets even worse. That's 54. So it looks like there's not a common difference, so this is not even arithmetic. So you can't get the common difference. You can't get the D because this is not even arithmetic to begin with. All right, and then you did number 4. Okay, so checking the common difference, we're subtracting 3 each time here. So yes, this one is arithmetic. And my D was -3. All right, so we also need to be able to write a rule or a formula for an arithmetic sequence. So here's the general format, kind of like what we were just looking at. on the previous page, we're going to be able to come up with those on our own. Oh, one more thing actually I want. My video cut off. Anyways, one more thing I wanted to show you, going back to the first page. Okay, right here, and I actually already did this, but the video didn't keep going. Anyways, so notice that both of these on numbers 1 and 2 were arithmetic. Notice that they're both actually linear equations. Okay, well, linear, you're thinking y equals mx plus b, right? That's linear. So basically there's no exponent on your variable, like the n is just plain old n. And also the n is not in the exponent either. So that's when it's always going to come out to arithmetic. There's always going to be a common difference, is when you just have a linear equation. Also notice that your d, your common difference, was actually just the slope of that linear equation, right? It's the number in front of the n that actually ends up being your d. Just something to notice there. Okay. Anyways, we have this general formula, and we need to be able to come up with our own formulas using this. So let's talk about what all these parts mean. The t sub n, that's just like your y equals at the beginning of an equation. So it's going to stay t sub n. T sub n, when I say sub, I mean it's down below. Okay, that's going to stay like that. This is your first term, right? Because it has a little 1. That means it's the first term in the sequence. And then, of course, our d is our common difference. Okay, you don't have to write the d behind the parentheses like that. It can actually also be written as t sub n equals t1 plus d times n minus 1. That way you remember you're going to distribute it into the parentheses. Later on, when you start to simplify, it might help if you write the d in front so that you remember you're going to distribute. Okay, either way, it's the same exact thing. Okay, so remember that t sub n just stays t sub n. All right, let's look at some examples. We're going to write the formula for the sequence. So the first thing you want to do is get maybe the common difference. So going from 5 to 10, 10 to 15, 15 to 20, what am I adding each time? 5. So my common difference is 5. What's my first term? 5. So let me actually move that down. So t1 equals 5. My common difference is 5. So now I can write my formula. T sub n equals 5 plus n minus 1 times 5. Again, you could have written that 5 in the front. I just got so used to writing it at the back that that's the way I tend to do it. But you can write it in front of the parentheses. Okay, so now distributing the 5 here, I want to simplify my equation. So 5 minus 5 cancels, and I just have 5n. Now you notice if you go back and like do t1, t2, t3, so I'm plugging 1 in for n, 5 times 1 is 5. If I do 2 for n, 5 times 2 is 10. If I plug in 3 for n, 5 times 3 is 15. So you can actually check to see if your answer is right, because yeah, the first 3 terms are 5, 10, 15. Okay, let's try the next one. Okay, we want to get the first term. So t1 is negative 21. Okay, to get from negative 21 to negative 29, you subtract 8. Now, if you couldn't figure that out, you just want to type it in your calculator. You do the term 2 minus the term 1. So negative 29 minus 21 minus negative 21. So negative 8. And then you could do the next one, negative 37 minus negative 29, also negative 8. So that's how you can see the common difference as well. Negative 8, negative 8. So D equals negative 8. Now we plug everything in. I'm going to put the D in front of the parentheses this time. Okay, now let's simplify it by distributing. And combining like terms. Okay, there's my formula. You could also write the negative 8n in front of the negative 13, so you could put negative 8n minus 13 if you want. All right, let's try number 7. Okay, so this is the exact same thing, except not only are we finding the formula, we're also going to use the formula to find this term. So that dot, dot, dot means, you know, we keep going and there's some other numbers there. And then they want to know what T56 is. So when n is 56. So first let's find the formula. T1 equals 2. My common difference is 8. So D equals 8. So writing my formula, Tn equals 2 plus 8 times n minus 1. So I could write 8n minus 6. So that's my T sub n. Now T56 is going to be 8 times 56 minus 6. 8 times 56 minus 6. 442. All right, and this is the last one we're going to do. Today we will finish these notes tomorrow. So let's take a look. Same idea. First term. Common difference. Okay, write the formula. How about pause the video and you guys go ahead and try to write the formula and then you can check. Okay, so there's my formula. And then I'm going to plug in 33 for n to get T sub 33. T33 equals 0.75 plus 0.25, whoops. Which comes out to 9. Okay, so that's where we're going to stop today. Now, we are going to do, you're going to get a worksheet now, and you should do numbers 1 through 6 today on the practice. And then tomorrow, after we finish the notes, you'll be able to do the rest of the problems, and it will be due at the end of class tomorrow. So make sure you go ahead and do 1 through 6 today so that tomorrow you'll have time to do the rest before it's due. All right, y'all have a great day, and I will see you tomorrow.